Hi students, so we're going to start at trigonometry. First of all, I'm going to define the trigonometric circle. A trigonometric circle is a circle whose radius is the unit of length. What do we mean by the unit of length? The unit of length, it means 1 kilometer, 1 centimeter. So the radius here, from here till here, it is 1. Okay, so it's a circle. You have a center O. This is the positive sense if you move counterclockwise. If you move clockwise, this is called negative sense. For example, if you want to go to 90 degree, this is 90 degree. Plus 90, you go upward till this point. If you want to go minus 90, you go down. Okay. If you want to go minus 180 degree, you go to that point. So this is a trigonometric circle whose radius, the unit of length is 1. If you move upward, it will be positive. If you move downward, it will be negative. You have a center. You have 4 quadrant. Quadrant 1, where x and y positive. Quadrant 2, where x is negative but y positive. Here x, the axis. Quadrant 3, x negative and y negative. Quadrant 4, x positive, however y is negative. For in this chapter, we're going to study two units. We're going in trigonometry. We're going to study the degree, and you want to study the radian. We all know the degree. A whole rotation, a full circle rotation, is a 360 degree. There is another one which is called radian. What is a radian? Radian, first of all, is not in degree. It's a number. The ordinary number, you know. And one of the well-known radian is the number pi, which is 3.14. So how did we discover the pi? The Egyptian discovered it when they built the pyramid. If you take any circle, you can do it as a project. If you cut this circle and you measure the length of the circumference, this length, which is the circumference or perimeter, and you divide it by the radius for any circle you want to draw. You can check it by yourself. For example, you're going to have a point which is 6.28, etc. So they name this number to be pi. So 2 pi, for example, 2 pi's, and the pi will be what? Half of it, which is 3.14. And 3.14, because we're dividing, guys, the circumference by the radius, it's a relation with the circumference. So instead of saying 360 degree, I can say that this whole rotation is 2 pi, which is 6.28. Okay, so we have two relation. You can do the degree. The degree, you already know the 360 degree, the rotation. Or you can do it vice versa to pi. To pi, it means a rotation, where pi is 3.14, and this is a number. So if you want to convert from degree into radian, so how do you differentiate between the two? In degree, you have degree. In radian, you don't have anything, just a number. When you have just a number, it means it is radian. So 360 degree, which is, as we said, a whole revolution, a whole turn. Okay, from the origin, you do a whole turn. It's the same as doing it as 2 pi. 2 pi, it means the same, a whole turn, but in radian, in number. If you have x degree, you convert it into y radian. So if you do over, so this is the relation between degree and radian. So 360 over x degree equal to pi over y radian. So we said 360 over x degrees equal to pi over y radian. Now we want to convert some well-known angle. We're going to use it most often in this chapter. It's radian. I want to convert this degree in radian. So 30 degree, if you replace here x by 30, you're going to get 360 over 30 equal to pi over y radian. If you do cross multiply, you're going to get y will be 2 pi 30 over 360, which is pi over 6. So from now and on, pi over 6 is the same as 30 degrees. So don't forget, you need to memorize it. And similarly, the 60 degree is pi over 3. The 45 is pi over 4. The 90 is pi over 2 if you replace it. And the 180 is pi. So if you have a circle, guys, suppose you have a circle here, trigonometric circle. We said that this is 0 degree. Here it's 90 because it's, you know, that this perpendicular, this is 90. If you go another 90 here, you have 180 degrees. If you have another 90, you go 270, and then you do the whole rotation plus another 90 here. I'm moving positive like this. You have the 360 degree, which is the same as 0. When you do 360 degree, you return to the same point. Similarly, you have remarkable angle. The 90, if you divide the 90 by 3 parts, each part will give you 30 degrees. So this is a 30, this is a 30. So the remarkable angle, this is called remarkable angle, 30 degree. Any multiple of 30 or 60, and this is 90, and this is 180, or half of it, which is 40. This is half. This is 90. The bisector is 45 degree. So in radian, the 30 is called pi over 6. So don't forget, you need to know it. The 45 is pi over 4. 45 pi over 4. 60 degree pi over 3. And the 90 degree is pi over 2. 180 is pi. Here is pi. Pi, you're moving 180 degree, and 2 pi, we're moving a whole rotation. Okay, so you need to memorize 30 degree, as I said, pi over 6 in radian, where pi is 3.14. 60 degree is pi over 3. 45 degree is pi over 4. 90 degree is pi over 2, and 180 is pi. And if you want to convert from radian to degree, what do we do? Why we know this is radian? Do you have degree anywhere? I don't have, so it's a number 2. When we have a number, so it means it's in radian. All number that you know, if you want to take it as measure of trigonometric circle, it will be radian, except if you put degree. So here you replace this y here this y by 2. If you do cross multiply, you're going to get x when you divide it by 2 pi, 3.14. So you're going to get 114.59. If you want to use, for example, 0.5, this is radian because I don't have degree, as I said. So you have these measures, okay? So as you can see, we have two different measures. We have the degree and we have the radian. Now I want to tell you something. Suppose you have a point M on a circle. This point M make with the x-axis an angle alpha. This is the angle. You can go positive sense directly to point M. One can tell me, okay, I want to do a whole rotation, one rotation, 360, then going to M. So this alpha can be written as alpha plus 360 degree. One can tell me, okay, I want to do two rotation, alpha plus 2 circle, then going to 360 degree. You want to do two rotation, 1, 2, 3, going to alpha, 4, going to alpha. So as you can see, alpha plus 360k, where k is an integer, it can be positive going positive sense or negative sense, the same as alpha. You can go, or you can go from that sense, minus 360, then going alpha. Always you need to know, when you go like this, it means negative. When you go like this, it will be plus. So if you want to go, for example, you have 30 degree. You can go directly to 30 degree, or you can do it in positive sense, or you can do minus 3, because I'm moving now backward, minus 360, then going up 30. So it will be minus 360 plus 30. In other words, for any angle you can add 360 or minus 360 or any multiple of 360 or minus 360. So that's why the 0 degree is the same as 360k, where k is the number of rotation. It can be positive or negative. Or in radian, 0 radian is equal to 2k pi. 2 pi is a rotation. 4 pi 2 rotation. 6 pi 3 rotation. 8 pi 4 rotation. Minus 2 pi is a rotation, negative. Minus 2 pi, another rotation, minus 6 pi, minus 8 pi, minus 10 pi. So even number of pi, or odd number or even number of 360 in degree, so it's the same as 0. In other words, 720 degree is 0 degree. Why 0 degree? Because this is 360 plus 360. Minus 4 pi is the same in radian, is 0. Why 0? And minus 4 pi, minus 2 pi is a rotation. Another minus 2 pi, minus 4 pi. Minus 6 pi is also 0. Now we're going to define what's sine, cosine. If you have a point M on this circle, you have the x-axis as you can see here, and you have the y-axis. If you project the point M on the, and we know that the circle is a trigonometric circle is a circle whose radius is 1, so maximum OA here is 1. If you project M, you do perpendicular from the M on the x-axis and the perpendicular from the M on the y-axis. So you're going to have a rectangle. Did you see the rectangle here? The projection on the x-axis, this system, which is this side, which is OP, is called cosine of angle what? Alpha. And this measure here will be sine of angle alpha. Tangent, if you do the tangent at point A and you do and you continue the line here, it will cut at any point T. This is the tangent. And if you take similar triangle, this triangle similar to that triangle, and you do the similarity, no need to do it. We can prove that sine alpha is a tangent alpha. This is something wrong. Tangent alpha equal sine alpha over cosine alpha. So what is sine and what is cosine and what is sine alpha over cosine alpha? Okay, so for any point M, you have an angle alpha. If you project M on the x-axis, you have a distance from the origin. This is called cosine alpha. If you project it on the y-axis, you have on the y-axis a side. This is called sine alpha. So the point M has 4 coordinates. Cosine alpha is sine alpha. And tangent, if you do as we said similar triangle here, you're going to get tangent alpha equals sine alpha over cosine alpha. For example here, it's alpha. Where is alpha? If this is the point M in the second quadrant, so this is angle alpha from the origin. This is angle alpha. So you have the point M here. So you want to do perpendicular on the x-axis. This is a perpendicular, and the perpendicular on the y-axis. So this is sine alpha here. This measure is sine alpha, but 100% it is positive because it's above the origin and less than 1. And cosine alpha here, because it's to the left of the 0, it is negative. In the third quadrant, this is angle alpha. Okay? If you do the projection here, so this is cosine alpha, which is negative, and this is sine alpha because it's below the origin, it's negative on the y-axis. If it's in the fourth quadrant, so this is angle alpha. You can do this alpha, or you can take this one smaller. How do you find this smaller? I'm going to give you an example in a while. So here, if you project on the x-axis, this is cosine alpha from here till here. If you project on the y-axis, this is sine alpha, and this is angle alpha. Let us take an example. Suppose I'm going to give you, we said, from here till here is 90, another 90, 180, 180 plus 90, 270. Let us take a 310 degree. This is 310 degree in the last quadrant. 310 degree, so I mean here, from here till here, it's a 310. Or this is positive sense, as we said. Or you can go negative sense. If you want to go negative sense, for example, this is all 360. If you take up 310, what remains 50? But since I'm moving negative sense, like down, it will be minus 50 degree. So you can use, as we said before, don't forget, for example, 310, you can add 360 or minus 360. Always try the angle to be between minus 360 and 360. So if you put minus 360 here, what do you get? You're going to get minus 50 degree. We're going to take examples in a while. Secant is 1 over cosine alpha. Cosecant is 1 over sine alpha. Cotangent is 1 over tangent. But since tangent is sine over cosine, cotangent will be cosine over sine. So, and since secant and cosine, if you do cross multiply, so secant and cosine, because they are inverse of each other, it will be 1. Cosecant and sine will be 1. Cotangent and tangent will be 1. So don't forget, sine is the projection on the y-axis of the on a point on the periphery. The projection on the x-axis is cosine. Secant, tangent is sine over cosine. Cotangent, cosine over sine. Secant is 1 over cosine. Cosecant, remember not to differentiate. This is S, this is S, cosecant. Here I have E. It's similar if you want to write it like C, E and C. Okay, so not to forget. And always sine and cosine is always between -1 and 1. You cannot have sine or cosine be bigger than 1 or less than -1. Always it must be of the form plus or minus 0 point. And because secant is inverse, so it must be bigger or equal to 1 in absolute value. For example, if you have 330 degree, tell me I want to add, since rotation, as we said, you can add any 360 you want, plus or minus. You can add minus 360, so it's the same minus 30 degree. So if you have a circle, 330, it's 90 plus 90, 180, plus 90, 270, remain 30 degrees. So this is the 330. Instead of going from here, this is the point M, okay? Going from here till here and say this 360, you can go 330 minus 360 is 30. So, but because I'm moving negative, I'm going negative to point M, so I say minus 30 degree. If you have 780, it's very, you have more than one rotation. So 780, we know that if you take out 360 from it, and another 360, so it will be minus 2 times 720 plus 780 is the same as 60 degrees. So what differs? It differs, we're spending more time, but we have the same angle. You can go directly to 60 degrees here, 60 degree, or you can do two rotation, 1, 2, then going to 60, then we do 780. Minus 212, if you don't want it to be negative, you can add to it what? All these you can add plus 360 or minus 360 or any multiple of them. It's the same as 148. And if you have 1055, it's a 3 times the 360 negative, certainly, because I want to write it in smaller angle. If you add to it 1055 is minus 25. If you don't want to if you don't like the negative number, what do you add at the end to it? You add 360, so it's 335. If you have it in radian, 5 pi, you know that a circle, a rotation is 2 pi. Here is bigger than 2 pi. You can take out 2 rotation, which is minus 4 pi, plus 5 is pi. So instead of saying pi is 180 degree, 1 pi, 2 pi, I'm moving 180, 3 pi, 4 pi, 5 pi. So directly this point here is a pi. 180 degree, a pi in radian. Minus 8.5 pi, you can take even number of pi. Every even number of pi is a rotation. So 8 pi minus 8.5 pi minus 0.5 pi. If you don't want it in negative, you add to it what? Plus 2 pi, a rotation to pi. Okay, so it is the same as 1.5 pi. If you have 3.41 pi, you can take out minus 2 pi, so it will be 1.41 pi. If you have a 11 pi, you can take how many? One rotation is 2 pi, so 5 rotation is 10 pi, remains what? Pi. If you have minus 17 pi, you can take 16 rotation, what remains? Minus 16, minus pi, sorry, we take out 16, remains a pi. So that's why periodicity, for cosine and sine, secant and cosecant, because they are inverse, if you add even number of 2 pi, 2k pi, as you can see here, plus or minus, it doesn't matter, nothing will differ. Or 360, 360, nothing will differ. But for tangent and cotangent, because tangent is sine over cosine, if it's in the first quadrant, if this is alpha, you go alpha, or you go alpha and then you add a pi, a line. This is a pi. Here pi plus 180. Pi is 180 degree. If you add alpha plus vertically opposite is another pi. From here till here is pi. Pi plus alpha. If you do the sine and cosine, if these are two positive, so these are two negative and equal. This one equal to that one and this one equal to that one. So that's why tangent and cotangent, the period of them is even and odd number of pi. What does it mean? It means if you have, for example, let us take here the example here. Cosine, here you have cosine. You can get rid of even pi. Here sine, I can get rid of even pi, as you can see sine alpha. Here I have odd, I have sine, I cannot take the odd, I can get the even. I can take out minus 12 pi, what remains? Minus pi, if I want to simplify it. Here secant is like e in the middle, like cosine. I can take the even, so I have minus 51 pi, so I take out 50, what remains? Minus pi. Here even and cosecant like sine, you can take the 24, it remains cosecant alpha. Here cosine, I cannot take the odd, remains one odd, I take out the even, which is 12 pi, which is 6 rotation in negative. Here I have odd, you can take 12 in a 6 rotation, so what remains? Sine alpha plus pi. In tangent and cotangent, I take out even and odd. Tangent, cotangent, I take even and odd number of pi, as you can see, all you take it up. Here sine, I take only the even, what remains? Pi. Here the secant, I take the even, what remains? It will be secant alpha plus pi. So always in tangent, if you have tangent, for example, alpha minus 23 pi. So I write, because I have the periodicity, periodicity it means repetition, of tangent and cotangent is even and odd, you can get rid of it. But however, if you have sine, cosine, secant, cosecant, whatever of these, if it's odd, you can take only the even. It remains what? Cosine alpha minus pi. You cannot take the odd. Okay? Now, these are, let us put the angles in a circle, degree first and the radian. The circle, we have 4 quadrants. This is 90 degree. And every 90, how many 30 you have? You have, if you divide 90 by 3, you have 330. So this is 30 degree. You split it into 3 equal parts. Another 30, this will be 60. This will be 90. This I'm writing it in degree. I'm not putting the symbol because I'm using the mouse. It's difficult to write in the mouse. Another 90, it will be 120, because every 30, here I have 330 also. I add to it, I'm moving, a point is moving on this curve. This is 30, then 60, then 90, plus 30, 120, plus 30, 150. This is 180 degree. It's a line from the origin. This is the origin here. Oh, from A I'm moving. Another 30, it will be 210. Another 30, it will be 240. This all multiple of 30 or 60 or 45 are called remarkable angle. This is 270 here. 270, you can see it's a 390s. 1, 2, 3, 90. So 3 times 90 is 270. Here, another 30, 300. Another 30 is a 330. And 0 is like 360. 0 or 360 degree in this. Now I'm going to move using radian. We said that this is pi over 2. We said that pi over 2 is 90 degree. Pi is 180. So if you want to divide, we said that 30 degree is, sorry, here 30. The 30 degree is pi over 6. So the 30 is pi over 6. In radian I'm writing now. From here till here I have 2 pi over 6. Twice pi over 6. 2 pi over 6. We know that 2 pi over 6, which is 60, you can simplify the denominator, 2 and 6, is the same as pi over 3. And that's what we found. Here I have 3 pi over 6. 3 pi over 6. We know that 3 pi over 6, we can simplify the 3 and 6. It will be pi over 2. And we know that pi over 2 now is 90. So I have 330. Instead of saying 330, I have 3 pi over 6. Then here I have 4 pi over 6. If you simplify it, you can see it's 2 pi over 3 here. 5 pi over 6. What does it mean 5 pi over 6? Read pi over 6 as 30. 5 times 30. 1, 2, 3, 4, 5. Here 6 pi over 6. 6 pi over 6 is pi. Here 7 pi over 6. Here 8 pi over 6, which is 4 pi over 3. 9 pi over 6. 9 pi over 6 is a 3 pi over 2. 3, listen guys, 3 pi over 2. What's pi over 2? Pi over 2 is 90. So I need 3 90s. 1, 2, 3 90s. Here 10 pi over 6. Here 11 pi over 6. Because every 90 we said you have 3. And the last one 12 pi over 6. 12 pi over 6, which is 2 pi. 12 pi over 6 is 2 pi. So you have it here. For 45, this is 45, we said it's pi over 4. Middle, the bisector. Pi over 4. How many pi over 4 till here? 2 pi over 4. 2 pi over 4 is pi over 2. From here till here, another 45. How many pi over 4? 3 pi over 4. You read it. 3 pi over 4. 3 times 45. Here 4 pi over 4, which is pi. Here 5 pi over 4. 545. 545. 1, 2, 345. 445. 5. 6 pi over 4, which is 3 pi over 2. 6 pi over 4, which is a 3 pi over 2. What does it mean 3 pi over 2? Pi over 2 is 90 in 3 90s. 1, 2, 3. 6 pi over 4 here, 7 pi over 4. 745. 8 pi over 4, which is 2 pi the whole rotation. So that's why, let us clean this mess here. You can go, these are the degree, the 45 here in the middle. You can go in radian, pi over 6, 2 pi over 6 as you can see, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6. 9 pi over 6, it means 930. 10 pi over 6, 11 pi over 6, and 2 pi, or you can move in radian. This is the positive sense and downward in the negative sense. What I want you to memorize, pi is 180, pi over 2 90, pi over 3 is 60, pi over 4 is 45, and pi over 6 is 30 degrees. Let us continue. Now I want to locate the angles. So we're going to locate the following angles. 5 pi. So this is the origin. Pi is 180. So this is 1. Sorry. This is 1 pi. Another pi, 2 pi. I'm moving positive, right? Let me put it here. This is the positive sense, upward. This is the negative sense. I want positive sense. So 5 pi, 1 pi. Pi is 180. 2 pi, 3 pi, 4 pi. Here even, here is odd. So 5 pi directly will be here. Always 4 pi even at the origin, at this point here. Let us put this O and this is point A, at the point A. And this is, for example, 0 pi, 2 pi here, 2 pi, 4 pi, 6 pi here, 0, 1 pi, 2 pi here, 3 pi here, 4 pi, etc. I want minus 3 pi. Minus 3 pi, you move negative now. If you want to move negative, minus pi, minus 2 pi, I'm moving negative, minus 3 pi. So it is same. 12 pi directly is point A. Minus 23 pi odd, it will be this point here. 8 pi, it will be here at point A. Okay? Now, how do you read pi over 2? Pi over 2, you read it. Pi over 2 is 7. Pi over 2 is 90. Don't forget, I told you memorize it. I want 7 90s. So this is 190. 1, 2. I'm moving 90. 3 90s. Circle is 490. 90 times 4 is 360. 5, 6, 7. So this is 7 pi over 2 here. 7 pi over 2. This point down. So as I said, pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5, 6, 7. I want minus 7, negative now. A circle is minus 4 pi over 2. then minus 5 pi over 2, then minus 6 pi over 2, here minus 7 pi over 2. Let me use the laser, you can see more. So I'm going to repeat 7 pi over 2, 1 pi over 2, 190, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5, 6, 7 pi over 2, minus pi over 2, minus 2 pi over 2, minus 3 pi over 2, minus 4 pi over 2, minus 5, minus 6, minus 7 pi over 2 here. I want 1390. I know a circle is 4 90s. 4 pi over 2. Another 4 is 8 pi over 2. Another 4, 12 pi over 2. Then I want remains 12 pi over 2, remains 1 pi over 2. It's here. So 13 pi over 2 is this point here. I want minus 21 pi over 2. You read pi over 2 alone. Pi over 2 is 90 degree. I want minus 21, minus 4, minus 4, minus 8, minus 4, minus 12, minus 16, minus 20, remains 1. So where will be minus 20 pi over 2? It will be here. Okay, so this is concerning pi and pi over 2. Now I want to go to pi over 6. How do we read pi over 6? Pi over 6, we take pi over 6. Let me tell you, everything k pi over 1, you read it as how many 180 degree? This is we said about it. Even here, odd here. K pi over 2, you read it how many 90? How many? 90. This is 90. K pi over 6, you read it how many? 30. K pi over 4, you read it how many? 45. Pi over 4 is 45. Pi over 6, how many? 30. Pi over 3, how many? 60. So f over 1, over 2, over 3, over 4, over 6, these are called remarkable angles. I want 5 pi over 6, so 530. I know in every 90 you have a 3. You can see 3 equal parts. 1, 3, 1, 3, 1, 3. So 1, I want how many 30? I want 5. 1, 2, 3, 4, 5. So this is 5 pi over 6. 530s. Every 90 you have a 3. Here I want 1330. A circle you have in every quadrant 330. 3, 6, 9, 12. Remains 1. So this is 13 pi over 6. It's like 30 degree. It's equal to 30. Because it's a rotation, then minus 31 pi over 6. Minus 31. I move negative. Negative downward. A circle you have 1230. Minus 12. A rotation. Another 12 minus 24. From minus 24 till minus 36, what remains? 7. Minus 7. Here minus 3 till here. Another 3 minus 6. The same point here that you have is the same as minus 31 pi over 6. Here I want minus 33 pi over 6. This is minus 31, minus 32, minus 33. Here minus 33. (17 pi over 6). I want 1730. 17. A circle is a 12 because every 90 you have a 3. 3, 3, 3, 3, 12. 12 plus 3, 15. What remains? 2. كلهم عم بيسقبوا هون. 17 pi over 6. This same point is 17 pi over 6. I want 20 pi over 6. 20, 30. 12 is rotation. Then remains 8. 3, 6, 7, 8. This is a 20 pi over 6. This point here. Then I want minus 25. A circle is negative now. Minus 12. Another 12 is minus 24. Remains 1. So this is 1 in negative. Like minus 30 degree. This is minus 25 pi over 6. Now I want pi over 3. Because 60 is not a multiple of 30. Instead of saying I want 560, do double 30. Instead of saying 530, it will be 10, 60, 10, 3, 6, 9, 10. So this is 5 pi over 3. Here I want 1360, pi over 360, like a 2630, a circle 12. With 12 at 24 remains 2. So here is 13 pi over 3. I want minus 31 pi over 3. Yani minus 62 30. Yani we know that 50 is a multiple of 12. Right? 50 no 60 is a multiple of 12 لأنه 5 times 12 so you have minus 5 rotation remains لأنه minus 6 2 remains minus 2 so this point here minus 1 minus 2 this point is minus 31 pi over 3 I don't have a space to write it okay I have here 33 pi over minus 33 يعني minus 66 so multiple of 12 is minus 60. What remains? Minus 6. So 3 and the 3. So this point here, the pi, the odd number of pi, which is the same, is minus 33 pi over 3. I want 17 pi over 3 and 34, 30. 12, 12, 24 remains 10. 3, 6, 9. This is the point. Okay, I have now, let me clean because it's all messed now. I want now 20 pi over 3, 20 in a 4, 26 in a 40, 30. So 12, another 12, 24, another 12, 36. What remains to 44? So here 3 remains 4. Here 3 and remains 1. So this is for 20 pi over 3. I want minus 15 and a minus double 30, minus 30, minus 12, minus 24 remains minus 6. From here till here is minus 3, here another minus 3, this is minus 15 pi over 3. Now we know that pi over 4, 45 degrees split the quadrant into 2 parts. The 30 split it into 3 parts as you can see. 45 pi over 4 in a 45. I want 545. From here till here I have 245. 445 and 145 it will be in the middle. Here 5 pi over 4. I want 13. The circle you have 845, 2, 2, 2, 2. In the 30 you have 12. Here 8. 8, 8, 8 is the 360 degree. So till 13 remains 5. 2, 4, 5. This is the same. Here is also 13 pi over 4. I want minus 31. Yani minus 8. Another 8. 5 times 8 is 40. لكن 4 times 3 times 8 3 times 8 is 24. What remains from 24 till 31 is minus 7. Minus 7. 1 2 3 4 5 6 7. This is minus 7. I move negative. This is minus 31 pi over 4. I want minus 33. Come in. Minus 33. If this is minus 31, minus 32, minus 33. This is minus 33 pi over 4. If you want to do it again, we know that 32, 8 times 4 is 32. You know, I have 4 rotation because 45 in a circle, you have 845. Minus 32 remains 1. So minus 1, I move down to the middle. 1745, 17, 2, 4, 6, 8, 12, 14, 16. This is 17 pi over 4. I want 11, 2, 4, 6, 8, 10. This is 11 pi over 4 here. So this is how we locate angles of remarkable angles in a trigonometric circle. So as you can see, it's very simple. I want you to redo these. Now, as we said, 0 pi over 2 is the first quadrant. Pi over 2 till pi, till 180. This is pi over 2. This is the second quadrant. Pi till 3 pi over 2. This is 3 pi over 2 because 390s, 190, 290, 390 is the third quadrant, and the last quadrant between 3 pi over 2 till 2 pi is the last one. In the first quadrant, cosine is positive and sine is positive. We talked about it before. So cosine and sine positive, tangent is positive. And concerning secant, it follows cosine. Cosecant, it will follow sine, and cotangent follow the sine of tangent because inverse of each one. In the second quadrant, cosine is negative, the x-axis. The sine is upward positive. You can see it here. Tangent is sine over cosine, plus over minus is minus. In the third quadrant, here you can see cosine is negative to the left of 0, and down elevation, cosine and sine are negative, so the tangent will be minus over minus positive. In the last quadrant, cosine, as you can see here, is positive. However, sine here is negative, and the tangent. So if I want to summarize it, in the first quadrant, cosine is positive, sine in the x-axis is positive, sine is positive, and the tangent is positive. In the second quadrant here, the x is negative, cosine negative, sine positive, and tangent minus over plus is minus. In the last quadrant, in the third quadrant here, sine is negative, cosine is negative, x and y are both negative here, and tangent minus over minus is positive. In the last quadrant here, cosine is positive, sine is negative because this is the elevation down here, okay, and tangent minus over plus is minus. Now I want to find the values of remarkable angle without the use of a calculator. Without the use of a calculator. Now I want to take the multiples of pi over 2. We said that a trigonometric circle is a circle whose radius is 1, and any point M, you have the abscissa is cosine alpha, and the y is sine alpha. If you have a point at the origin, like the point here 0 degree, so we have cosine 0, so the component, forget the circle, this is x is 1, I don't have y here because it's on the x-axis, you have 1. So what will be y of this point? 0. So because I'm on the x-axis and this is 0 degree, so cosine 0 is 1, as you can see here. Sine 0, I don't have sine because y is 0 of the point, is 0. Tangent is sine over cosine, 0 over 1 is 0. Now secant is inverse of cosine, 1 over 1 is 1. Cosecant inverse of sine, 1 divided by 0 is undefined, you cannot divide by 0. Cotangent is cosine over sine, or 1 over tangent, or cosine over sine, 1 over 0 is undefined. So the most important is to know these three, because the rest will be the inverse. If you have 90 degree, which is pi over 2, as you can see, the components of the point here is 0, this is the cosine, 90, or pi over 2, the x-axis, and this is sine, 90. So cosine 90, as you can see, I don't have abscissa. If you have y-axis, this is abscissa. I don't have abscissa, so cosine 90 is 0 because the abscissa is 0. Sine 90 is 1. Tangent is sine over cosine. 1 over 0 is undefined. If you have 180 here, so the point here is minus 1, x is minus 1, y 0. So cosine 180 is minus 1, and sine 180 is 0, and tangent is sine over cosine, 0 over minus 1, 0. If you have the 270 degree or the 3 pi over 2, 390s, a cosine is 0 because it's on the y-axis. The sine is minus 1. So now, from now on, I don't want you to memorize anything. Listen, guys. So if you have a circle, 0 degree is here. This point has 0, 1. Sorry, this point has 1, 0. So cosine 0 is 1, sine 0 is 0. This point here is 0, 1. So this point is 90 degree. Cosine 90 is 0, sine 90 is 1. This point here is minus 1, 0. So cosine 180 or pi is minus 1. Sine 180 is 0. This point is a 3 pi over 2 and has for component 0, minus 1. So cosine 3 pi over 2 or 270 degrees is 0. and sine 3 pi over 2 is minus 1. And tangent is sine over cosine. It's very simple to use. Now, if you have a multiple of 30, you remember this year, we took a triangle when you have 30, 90, and 60. And this radius is 1. What I want you to know, you can do the triangle property and find all sides. If you want to find this side will be half, and this side will be radical 3 over 2. What I want you to do, to know, if you have a multiple of 30 or 60, these are all multiple of 30 or 60. No need to memorize anything. Either the cosine is radical 3 over 2 or half, plus or minus, or sine is a plus or minus half radical 3 over 2. As you can see all. Radical 3 over 2 is 0.8, I think. Radical 3 over 2 is 0.866. Half is 0.5. So how do we know what is the cosine and what is the sine? What I want you always to bear in mind, except these 4 points, then we did it up, except these 4 points. If you have any angle multiple of 30 or 60, cosine and sine is a plus or minus half or a plus or minus radical 3 over 2. How do we know? Let me tell you, and I'm going to return to 45. So if you want to find minus 5 pi over 6, I read it as minus 5, 30. Pi over 6 is 30. I go, this is the 30 degree. 1, 2, 3, 4, 5. This is the point. This is minus 5 pi over 6. So you do the projection. This is the sine, this is the cosine, sorry, this is the sine. You can see that the cosine is bigger inside as the sine. The bigger one will be radically 3 over 2. So cosine minus 5 pi over 6 will be the biggest number, but since negative, I put minus radical 3 over 2. The sine is the smallest one, which is minus half. Tangent is sine over cosine, sine over cosine. You look at radical 3. Where radical 3, sine over cosine is in denominator, so I put it as 1 over radical 3. I want 17 pi over 4, I will return now in a while. I want 17 pi over 6. 17, circle is a 12, 13, 14, 15, 16, this is 17. So I do the rectangle. You can see that this is the sine, the smallest distance, and this is the cosine, the biggest distance. Cosine negative, sine positive. So cosine 17 pi over 6 is minus radical 3 over 2 here, and sine is half. And tangent will be sine over cosine. Sine over cosine, minus over positive, this must be negative. Sine over cosine, radical 3 is in denominator, so it's 1 over radical 3. If I want to do 17 pi over 3, we know that 17 is 34, 1760 is 34, 30. 34, 12, with 12, 24, remains 10, 3, 6, 9, 10, here. So I graph the rectangle. So the cosine is the smallest, as you can see, and the sine is the biggest. So cosine, I write cosine 17 pi over 3, the angle, always cosine of an angle here. The cosine at the smallest angle is half, positive. However, the sine of 17 pi over 3, the sine negative, because in the third quadrant sine, fourth quadrant sine is negative. The biggest distance minus radical 3 over 2. Because you all know in a triangle, if you have one angle is 30, the other 190, if you do here any triangle, 90, 60, if this is one of the side will be radical 3 over 2 and one of the side will be half, or vice versa, depend where the angle is. So that's why any multiple of 30 or any multiple of 60, except these four that we did in a while, multiple of 90, is either half or radical 3 over 2 plus or minus. And if I want to do tangent is sine over cosine. You can see radical 3 is up, so it will be minus radical 3. Okay. Now I want minus 27 pi over 3, so minus 54. Let me clear everything. minus 54. So I have minus 12, minus 12, minus 24, another 24, minus 48. Minus 48 till minus 54, I have minus 6. Minus 3, minus 6. So this point here. So this point here, it doesn't have anything to do with the radical 3 over 2 or half. So the coordinates of this point is minus 1 and 0. So that's why cosine of minus 27 pi over 3, the cosine is minus 1, the abscissa, the sine is 0. Tangent is sine over cosine 0 over a number 0. However, if you have minus 17, so this is minus 12, and 3 minus 15, minus 16, minus 17. If you do the projection here, this sine is the smallest one, negative, so sine will be minus half, as you can see. Cosine will be what? Minus radical 3 over 2, and tangent is sine over cosine. So let us do more problems here, application, and I will leave pi over 4 till the end. So let me do this problem. If you want to do 5 pi over 6, 1, 2, 3, 4, this is 5 pi over 6. The cosine of 5 pi over 6, the cosine is the biggest distance, radical 3 over 2, but negative. The sine, I'm not going to write again 5 pi over 6, sine alpha I'm going to put. The sine is the smallest distance. You can see this distance is bigger than this distance. So half. And the tangent, what will be? Minus over positive over negative is minus. Sine over cosine, radical 3 is down, so it will be 1 over radical 3. If you want to do minus 33, so circle is minus 12, another 12, 24, till 33 remains 9. 3, 6, 9. So here, this point here doesn't do anything with the radical 3 over 2 and half. The components of this point are 0, 1. So cosine minus 33 pi over 6 is 0. You're right. Cosine minus 33 pi, sorry, I have 3 here, over 6 is 0. Sine minus 33 pi over 6, whatever, is 1. Tangent is sine over cosine. 1 over 0 is undefined. If you want to do 17 pi over 6, a circle is a 12, plus 3, 15, remains 2. It's the same as this one that we did here. 20 pi over 6, 12, plus 6 is 18. Here remains 2. So here. So you can see for 20 pi over 6, the cosine is minus half, the smallest distance. The sine is minus radical 3 over 2. So cosine of 20 pi over 6, the smallest one, is minus half. However, the sine of 20 pi over 6 is minus radical 3 over 2. If you want to do tangent, tangent is sine over cosine. Minus over minus is positive, so radical 3 is in the numerator, it's radical 3. And if you want to do minus 25, so minus 24 to rotation, this is minus 25. I'm going to do it orally. The cosine is the biggest distance, positive radical 3 over 2. Sine is minus half. If you want to do tangent, it will be sine over cosine. Since cosine is the radical 3, it will be minus 1 over radical 3. If you want to do the pi over 3, it means I have 5, 16, 10, 30, 10, 30, 3, 6, 9, 10. So the cosine of 5 pi over 3, the cosine, I'm going to put C, cosine of angle 5 pi over 3 is half, the smallest one. The sine of 5 pi over 3 is equal minus radical 3 over 2, because the biggest this is tangent. And tangent of 5 pi over 3, it's sine over cosine. لأنه sine is radical 3, so it's minus radical 3. If you want to do 17 pi over 3, all are the same. So it's 34. We know the circle 24 to rotation remains 10. 3, 6, 9, 10 is the same as this one. If you want to do this one, minus 66. So, or you can say minus 66. يعني we know that minus 60 is a rotation, remains minus 6, minus 3, minus 6. So it's this point. It has components minus 1, 0. So the cosine is minus 1. The sine is 0. And tangent is sine over cosine. 0 over 1 is 0. If you want to do, for example, this one, 20 pi over 3, it's 40. 20, 16, 40, 30. Circle is 36. Remains 36. Uh, 36 is a multiple of 12. 36 till 40 remains 4, so it's here. So the cosine is minus half, the sine is radical 3 over 2, and the tangent will be sine over cosine. Now for 45 degree, you know, when we took the triangle before, if this is 90, 45, 45, so if this is A, this will be, if this is the diagonal, we said in the, we did it in the set and you did it last year. If this is A, this is A, this will be A radical 2. So if you do it, so always you have sine and the 45 in the middle. Sine and cosine for 45, multiple of 45, except these 4 points, it's always either radical 2 over 2 or minus radical 2 over 2. I don't have more than one number. It's either a plus or minus. So let us take some examples of 45. If you have 11, let me clear here. If you have 11 pi over 4, how many 45 you want? 11. We know that a circle is 8. 8 till here 10, this is 11. For 11, this I'm doing multiple of 45, not 30. So always radical 2 over 2, and tangent cotangent always 1 or minus 1. You can see here the cosine is negative, so I say cosine is minus radical 2 over 2. And the sine, I write it as radical 2 over 2. As you can see here, and the tangent, same number, but 1 is negative, so minus 1. If you want to do 13 pi over 4, the circle is 8, 10, 12, 13. This is 13. So if you project, as we said, it's always radical 2 over 2 and radical. The cosine is minus and the sine is minus radical 2 over 2. Both are the same. And the tangent minus over minus, it will be plus. So multiple of 30 or 60, half or radical 3 over 2 plus or minus. Multiple of 45, it's either plus or minus radical 2 over 2. And concerning these points, the multiple of 90, the first one is 1, 0, here 0, 1, here minus 1, 0, here 0, minus 1. Let us do that of, sorry, this one, the pi over 4. Sorry. I want 5 pi over 4, 2, 4, 5. Sorry, here, 2, 4, 5. This is 5 pi over 4. So the cosine is minus radical 2 over 2. The sine is minus 5 pi over 2, and the tangent will be 1, minus over minus. I want 13. Circle 8, 10, 12, 13. It's the same. Let me put it 15. 8, 10, 12, 14. This is 15. So, because multiple of pi over 4, always radical 2 over 2, the cosine is radical 2 over 2 positive. The sine is minus radical 2 over 2. So tangent is minus 1. Here I want minus 31. 8, another 8, minus, move negative. 8 minus 8, minus 24. From minus 24 till 31 is minus 7. So 2, 4, 6, I'm moving negative. So this is minus 31 pi over 4. Since multiple of 45 first quadrant, so radical 2 over 2 the cosine, and the sine is also radical 2 over 2, and the tangent will be 1. 11, 2, 4, 6, 8, 10, 11. It's the same at this point. The cosine is minus radical 2 over 2. The sine is radical 2 over 2. And the tangent is minus 1. Here, there is a diagram. It summarizes everything. As you can see, if it's a multiple of 30, these are all, the blue one, you can see, it's either half or radical 3 over 2. For example, here, if you draw, the cosine is the smallest one, positive, you put half. The sine is the biggest one. Here, if you take this point, the cosine is the biggest one, and the sine is the smallest one. So as you can see, so by locating the angle, and if the location was correct, if it's a multiple of 30, plus or minus radical 3 over 2 or plus or minus half. If it's 45, the red one, it's always radical 2 over 2 plus or minus. And if there are the 90 degree, it's either you can see 1 0 0 1 minus 1 0 or 0 minus 1. So this is your program for next time, for next Monday. You have for next Monday to convert from degree to radian, to convert from radian to degree, to locate remarkable angles in radian, and to find sine, cosine, tangent of remarkable angles. I know it's 1 hour video, but you know the trigonometry is very important, and I need to give more examples so that you will understand. So see you on Monday.